So working with logarithms, the point of logarithms, there's a couple. Number one is you can make really, really big numbers into a smaller scale, like the Richter scale or decibels. So something like 10 to the 6th power would just become 6. That's one reason. The other is it helps you solve equations when the variable is in the exponent. And you can't just take the root. When a variable's in the exponent, you can't just take the cube root or the square root. It doesn't work. So logarithms, the formula, what you have to be able to do to help solve is go back and forth between logarithmic form, which looks like this, logarithmic form, which looks something like log base b of x equals y. That's logarithmic, and exponential form would be like this. This is how you do it. You take the base b raised to the y power equals x, and that's exponential form. And these are inverses of each other. One undoes the other. So by rewriting something that's in exponential form as a log, or writing something that's written as a log as exponential, that helps you to simplify expressions and solve equations if you understand this translation from one to the next. So let's look at some specific examples using that. So we'll start with, we'll do a bunch of skills here. These are like, test objectives. Rewrite in exponential form is the first skill. Rewrite in exponential form. So let's say we have log base 3 of 81 equals 4. That's in logarithmic form. And I want to rewrite it in exponential. That's it. So you go like this. You take the base 3 raised to the 4th power. This is the exponent. Raised to the 4th power equals 81. And indeed, this makes more sense to us. We know that 3 to the 4th power equals 81. We've seen it. We're familiar with it. We're not as familiar with log form. So we have to practice going back and forth. That's so second example, log base 7 of 7 equals 1. That's logarithmic form. To translate to exponential, you take the base 7. The base is always here, this little subscript. The exponent is always here, raised to the 1 power, equals, and the answer is here, 7. And sure enough, we know 7 to the 1 is 7. A couple more examples. Let's say we have log base 14 of 1 equals 0. So what's that in exponential? Base to the 0 equals 1. And because we know 0 exponents, anything to the 0 power is 1, we know that works. And one more example with a fraction in it, log base 1/2 of 32 equals -5. Okay, let's check to see that works. You would say 1/2 raised to the -5 power equals 32. And let's just, to check this, we know to make a negative exponent, this is good review, to make a negative exponent positive, we take the reciprocal, which is just 2 to the 5 equals 3/2, and yes, 2 to the 5th power does equal 3/2. So that's one skill. The next skill is to evaluate expressions. Evaluate. So let's say we have, we're going to evaluate, so let's say we have, this is example number 5. Let's say we have log base 2 of 32. Okay? we want to say what that is. Log base 2 of 32. What is that equal to? So to understand what this means, you really need to write this. This sentence will help with everything with logs. This means 2 to what power, 2 to what power gives 32. In your mind, when you see this and you're trying to figure it out, you should say that in your mind. The base is 2. 2 to the what power gives you 32. And what is that? Yes. You're trying to find the exponent that when you take the base to 2 to this exponent, you get 32. Let's try another one. Let's evaluate the log base 27 of 3. That's a little trickier, but all you're saying is 27 to what power gives 3? Question mark. So to answer that question, I'll write it as an equation so you can see it better. You're saying 27 to what power? We don't know. We'll let that be a variable x. We don't know. Equals 3. 27 to what power equals 3? So you're going to need some kind of fraction here, because obviously it's less than 1. 27 to the 1 is not 3. We need something smaller. So yes, we want to take the cube root of 27. And the way you take the cube root is 1/3. And that's why we studied fractional exponents. So if you don't see that, what you can do is rewrite 27 as 3 cubed. Oh, I'm not sure I want to go into this right now, but the answer is 1/3. And we'll talk more about like a process for that. But let's try this. Log of 12. Log of 12. Okay, so when I want to evaluate, when you don't see a base here at all, that is called the default. You know, just like with square root, we don't see a little 2. The default base is 10. The default base equals 10, and the word for that is common log. And you can do this on your calculator. If there's no base, if you don't see a base there, it's base 10, and you can type on your calculator log of 10, and what it does is it's saying 10 to the what power equals 12. And you know intuitively that it's a little more than 1, right? But it'd be really hard to get it exactly. So if you do on your calculator log of 12, go ahead and do that. Yes. So do on some of these, you have to do on your calculator. If it isn't something obvious, do on calculator, and you're going to get 1.08 if you press the log button. There's a button, I can help you find it later. Sometimes it just looks like that, log on your calculator, and that makes sense that it's about 1.08. And then the last thing is something called natural log, ln. It's not a person named Ellen, it's ln, natural log of 24. I used to have a student whose name was Ellen, and whenever I said ln, she would like think I was calling on her. Okay, the natural log. This means base equals e. Remember how we studied, we did all the exponential expressions with the number e? This means that the base is e. Base equals e. So what it means is you can translate this like this. It's log base e of 24. Okay? And there is a button on your calculator, and it looks like this, surprisingly, ln, on your calculator that will do this, and it says e to the what power equals 24. E, what number is E approximately equal to? About, you remember the constant E is about what? About 2, right? So you would expect 2 to the what is 24. You would expect it to be about 4, 3 or 4. So what is it on your calculator? Do ln 24. Good. Good. You have to do it on your calculator, and you're going to get 3.18. Okay, and this, the word for ln is called, the word is natural log, and it means base E. And it does, you do not have to learn a new concept to do this. It's simply base E. It's just like base 10 or base 3 or base 5. E is just a number that happens to be 2 point something.